Welcome to Mr. Lehman's Knowledge Explosion. In this video, I'm going to be walking you through different examples that use the parallel line theorems, like corresponding angles are congruent or alternate interior angles are congruent, to find missing angles in a diagram. So let's start with number one. In diagram number one, you should have marked on your diagram that these two lines are parallel. If those two lines are parallel, I can look for different relationships. What I noticed right away is that angle X and 75 are corresponding. Remember, corresponding, one of the angles will be interior of the two lines, one of them will be exterior, but they're on the same side of the transversal. Well, if those lines are parallel, that means that these are congruent, so X is 75. When I look at angle 40 and angle Y, the transversal that creates those two angles is coming down across the parallel lines. 40 is on top, Y is underneath. Those would be considered consecutive interior on the same side of the transversal, interior of the two lines, but consecutive interior are supplementary. So that means Y plus 40 would equal 180 degrees, so Y is 140. And that's how we're going to answer these questions. Example number two. Again, I apologize, these are supposed to be marked parallel for you. I forgot to do that when I printed off your workbook. If the lines are parallel, then I get the corresponding angles congruent or alternate interior and things like that. Sometimes though, you're going to have to jump around the picture. The first thing I'm looking at is the 70 degrees and the X. The transversal that creates both of those would be this line as it cuts across these two. So 70 is here and X is here. Those are consecutive interior angles, which if the lines are parallel, and they are, then those are supplementary. So that means X has to be 110 to add up with 70 to be 180. Now the 3Y plus 8 does not have any relationship with the 70 or the X directly. However, 3Y plus 8 would be corresponding to this angle down here, which would also be 3Y plus 8 because corresponding or congruent when the lines are parallel. 3Y plus 8 down here and the 70 now are a linear pair, which means the 3Y plus 8 plus that 70 should equal the total 180 degrees for the line. And now I have an equation that I can solve. 3Y plus 78 would equal 180. So 3y would equal 102, which when I divide by 3, I'm going to get y is equal to 34. So y in this example is 34. And we're going to continue through the page answering questions just like that. Now when you get to number 3 is a little bit more difficult because there's different lines and they don't extend like they did in the first two examples. Well, that's okay. Start by identifying the transversal. I'm going to find angle X first. Angle X has this vertex, and 70 has this vertex on the same line. That means that line is the transversal, so when this line came down and created 70, and this line came down and created X, now it's much more clear to me that 70 and X are corresponding angles, and if the lines are parallel, those are congruent. So X is going to be 70. Now I'm going to start over and I'm going to try and figure out what the relationship for Y is and what angle it links to. Y has this vertex up here, and 40 has this vertex down here. So that means this line is going to be a transversal. So if I draw that transversal, I am cutting this line coming down and this line coming down to create the 40 and the Y. So those are the two that I'm going to look at. So this line came down to create Y, this line came down, but 40 is in the top up here. While looking at those, I see that they're both inside the two lines that I drew, but they're on alternate sides of the transversal, so those are alternate interior. Alternate interior are congruent when the lines are parallel, so Y is 40. Now I'm going to do the same thing to figure out what Z is. So I'm going to start over. I'm going to say, okay, Z has a vertex here, 40 has a vertex on that same line, which means this line is my transversal. So I always draw the transversal, first. That's cutting across this line coming down, z is underneath, and then it's also cutting down across this line to make 40. So I draw those two lines, and I get 40 up here. Those are also alternate interior angles, which means they're congruent when the lines are parallel. So z is also 40. So for this worksheet, I apologize. I was supposed to mark these with the triangles or the arrows to say they're parallel. I forgot to do that when I copied this book off. So if it looks parallel on this worksheet and this worksheet only, please treat it as parallel and use it that way. Example number 4. Again, the two that should be parallel would be here. Lots of different relationships I could start with. What I notice right away is that 12x and 120, that's a linear pair. And I know linear pairs are supposed to add up to 180. So 12x plus 120 should be 180, which means 12x is going to equal 60 when I subtract the 120 from both sides, divide by 12, and I get that x is equal to 5. Now, looking at the parallel lines, I'm going to find z, because I noticed that z, the 5z, and the 50 are on the same line, so that's going to be the transversal. So I will draw the transversal, which is cutting the top parallel line to create 5z, and the bottom parallel line to create 50. Now here you got to be careful. Hopefully you're noticing that these are corresponding, and corresponding angles are congruent, but you've got to say 5z is equal to the 50, not just z. So then I divide both sides by 5 and I get z is equal to 10. Now for the 12y plus 10, I've got a couple different options. Since we know that x is 5, I know that 12 times 5 makes this angle 60. And what I'm seeing is that 60-degree angle shares a vertex on this line, same as the 2y plus 10. So when I draw that transversal and the 60 and the 2y plus 10, what I notice right away is that those are alternate interior. So that means those are both equal to 60. So that means my 2y plus 10 equals 60. So 2y is equal to 50. So when I divide by 2, I'm going to get y is equal to 25. So the whole idea here is to recognize the relationships and use them to find the missing angles in the picture. Let's do number 5. In number 5, the parallel lines you're supposed to get are here and here. So let's see, I'm noticing that x and 70 are on that same line there, so that's my transversal. Cutting across this line to make 70, cutting across this line to make x. Well, that means 70 and x are alternate interior, which makes them congruent because those lines were parallel. Now y and 60 have the vertices on this line right here. So that line is going to be my transversal. So there's my transversal cutting across the parallel making y, cutting across the parallel making 60. Now y is exterior of the two lines, but 60 is interior. Those are going to be corresponding, which are also congruent when the lines are parallel. So y is 60. Number 6 here in your notes, you're supposed to get that all three of these are parallel lines. So what I noticed right away is 110 and x plus 4y are on the same line, which means that's the transversal. I like to resketch it, so I've got the transversal cutting across the top line making 110, cutting across the middle line making the x plus 4y. Now those two angles are consecutive interior, which means they should add up to 180 degrees, which means this x plus 4y is equal to 70. Now I've got the same relationship further down because this line will be a transversal for the 3x plus 2y and the 120. So I'm going to draw that transversal cutting across the middle line to create 3x plus 2y and cutting across the bottom line to create 120. That's the same exact relationship, different transversal, but they're consecutive interior angles, which means this will equal 60 because consecutive interior angles add up to 180 degrees, and 120 plus 60 is 180. So this is just going to take more algebra to solve. If you look at what you have here, you have one equation that has x and y, and you have a second equation that has x and y. So my algebra is going to be putting those two together. 3x plus 2y equals 60, and the x plus 4y equals 70. So this is a system, and I need to eliminate one of the variables. The easiest way I see to do this would be to multiply the top equation by -2, which would turn that into -6x minus 4y equals a -120. Remember, you got to multiply all the terms in that equation by that number. And now the 4y and the -4y would eliminate if I added straight down. So x plus a -6x is -5x. The 4y minus the 4y is 0. And then 70 plus a -120 is a -50. So I have the equation that says -5x equals 50, so when I divide by -5, I get x is equal to 10. Now to figure out y, I just got to go back into one of those equations. It said x plus 4y was equal to 70, but if x is 10, that means 10 plus 4y is equal to 70, or 4y is equal to 60 when I subtract the 10 from both sides. Divide 60 by 4 and I get that y is equal to 15. So you may run into some more algebra on problems like this, but the whole problem started by recognizing that I had consecutive interior angles, and I set up an equation the way that those were supposed to. So use the theorems to set up equations and then solve those using your algebra skills. Those are the first 6 problems. If you have any more questions on the others, please ask. In the future, I'll post a video over those as well to help you out so you can see all the examples from your workbook. Good luck.